Hi, so we're going to go ahead and talk a little bit about integers, or sorry, not integers, we're going to talk about variables in Java. So essentially what we have is that we are going to take a look at the primitive data types of Java to start out with. So what we have is we have 8 primitive data types. We have byte, short, int, long, float, double, Boolean, and char. Okay? So the majority of these are numbers. So byte, short, int, long, float, and double are all numbers. So what's the difference between the two? Well, basically each one takes up more memory than the last and has a greater data range. Okay, so a byte is an 8-bit signed integer, okay, and the range goes from -128 to 127. The reason why you'd use a byte versus a short is that you'd want to save memory, right? It takes less memory to store 8 bits than it does to store 16 bits for a short. Also, it serves as a way to clarify your code. If you define a variable as a byte, you're saying that permanently that variable will never go less than -128 and will never be more than 127. Okay, so next we're going to look at short. So short is similar to byte. This time it's 16 bits. The minimum value is -32,768. The positive value is 32,767. And it's the same thing. If you have a piece of data that you know is never going to be less than the minimum or more than the maximum, okay, so but then it's the same situation where remember that this has to be an integer, right? So we're talking about integers here, and when they say integer, it means that if it's something that has a decimal, that you will lose that data, and we're going to take a look at that in just a second. Okay, the next one is int. Int is a 32-bit integer, basically, and it has a much larger range, right? We have -2 to the 31st, and 2 to the 31st minus 1. There's the range. It supports arithmetic operations. So the int class is one that we will use in our videos. Then we have long and float. These get a little bit more, you can store more values in them. Also, long and float are the first decimals that you can use. And then finally is double. And double is the most versatile primitive type. So the double data type is the number type that we're going to use primarily. Okay, so we do calculations. In general, we're going to use the double data type for common programming tasks. If it's a decimal, or use the integer if we want to just have an integer for common mathematical tasks. Now, the one thing that needs to be said here is that, there is a limit of precision. So if you are doing some kind of scientific calculation, then you're going to need to go into this Java Math Big Decimal class. And basically what that's going to allow you to do is to control how the computer is rounding, so control the precision of the calculations, and it gives you complete control over that. So these primitive data types, you kind of have to choose which one is the best for you. In general, it's going to be double. If memory is a real problem, if you're storing lots and lots and lots of data, you might want to use something else. But in general, double is going to do it for your decimals. Okay, so the next data type is going to be Boolean. So basically, the Boolean data type has only 2 possible values, true or false. So it's an on or off situation, right? So it's either true or false. It's 1 bit of information, so it's a 0 or a 1. Boolean will be used quite a bit. In general, if when there is logic in a programming, using the Boolean data type. And then finally char. So the char data type is a single 16-bit Unicode character, has a minimal value of this and a max or 0 and a maximum value of this, or 16 or 65,535 inclusive. Okay, the main area that we'd be using the char data type, I'm not even sure I'm saying that right. I never know whether it's char or char. Okay, so I'm assuming char for character. Mainly where we're using the character data type is as it's going to make up the string class, right? So strings is really where we're going to be using. So in addition to the 8 primitive data types listed above, the Java programming language also provides special support for character strings via the Java language string class. Enclosing your character string within double quotes will automatically create a new string object. For example, string s equals this is a string. String objects are immutable, which means that once created, their values cannot be changed. So the string class is not technically a primitive data type, but considering the special support given to it by the language, you'll probably tend to think of it as such. You learn more about the string class later on. So today we are going to concentrate on integers and doubles. So the 3 data types that we're going to use most in this series of videos is that in this course is the while we're doing Java is the int, double, Boolean, and string. Okay, those are the main types of data types that we're going to use. Okay, so let's talk a little bit about data type casting. Okay, and here we're going to do a couple of experiments, and you should be doing these along with me in your IDE in just a second. Okay, so it's really tough that we have to talk about casting right away, but casting is, it's one of the issues in a language like Java. So Java supports 2 types of casting, and casting just means that determining what data type any given variable is. Okay, so basically, and changing that data type. So if I want to take an int and I want to turn it into a double, that's called casting. So I have a variable that I've defined as an integer, and I want to take that value and put it into a variable that I've defined as a double. That is casting. Okay. So it comes with some very strict rules and explained clearly in object sorry. So the primitive data type casting and reference type casting. Okay, so let's talk a little bit about these. So Java data type casting comes in 3 flavors: implicit casting, explicit casting, and Boolean casting. Okay, so the one that we have to worry most about, in my opinion, is implicit casting. Okay, because of implicit casting, the risk is that Java would do something with our data that we wouldn't be aware of, right? So that's the real risk in programming to things that are implicit. Okay, implicit means that you don't do anything, Java just does it automatically. Okay, so so implicit casting means that a data type of lower size, which occupies less memory, is assigned to a data type of higher size. Okay, the lower size is widened to the higher size. This is also named automatic. This is also named automatic type conversion. Okay, so let's do this. So we have integer x equals 10, double y equals 10 equals x, system print y. Okay, and it's going to print out 10. Okay, so notice that in this sample code, it's telling us what it would print. Okay, so there we have the same value of 10. As an integer, it occupies 4 bytes. As a double, it occupies 8 bytes. Okay, that's 8 bytes in memory, right? And then if we print it out, double would print out as 10.0. Okay, so let's just give this a try. So we're going to go ahead and we're going to run a couple of experiments, and you should do these along with me during the video. This is a great way, just experimenting with running code is a great way to learn stuff while you're starting to program. And a lot of times, it's faster than looking things up. So if you wonder what's going to happen when you do something, sometimes it's just faster just to do it and just see the output, and then look up the details later. Of course, there never is any any substitute for reading the documentation. Okay, so we're back in our IDE. We're going to go File, New Class, and we're going to call this Variables int double. Okay, and we're going to click. We want them to write our public static void main for us. We're going to click Finish. Okay. So the first things first, let's take a look back at our sample code here. And so we're gonna create an integer that is x, that has a value of 10. And then we're gonna create a double that is which is y, which is equal to x. Okay? And then we're gonna print out their values. Okay, so we're gonna do int x equals 10. Double y equals x, and then we're going to say I always forget my capital on system for some reason. I don't know why I do that. Okay. So you're going to print the line out. Okay. And we're going to go int equals okay. And we're just going to throw it in there. And then we're going to copy and paste. Whoops. And then we're going to put our double equals y. Make sure to put on our semicolons, right? Okay, so now we're going to go ahead and run this. Okay, and notice that in our output here, that our int prints out as 1, 0, and our double prints out as 1, 0.0. Okay, so notice that the double prints out as a decimal no matter what. So that's a good way to tell if something is an integer or not, right? Okay, so there is all kinds of formatting that can be done to these doubles, all right? You know, there's lots of different ways that numbers are displayed. You know, if it's currency, if it's you know, a decimal value, if it's you know, if you're formatting it one way or the other. There's just a lot of different ways that numbers have to get printed out. There's a whole kind of language inside of Java that is used to print out these numbers. They're formatters for the numbers. Okay, for now we're not going to worry too much about that. For now we're just going to concentrate on ints, which are integers, doubles, which are, for our purposes, they're decimals. And let's find out a little bit more about this. Okay, so we're going to go ahead and add a little bit more code here. Okay, so we're going to have an int, and we're going to call it add. Okay, actually we're going to call it divide. And our integer that we're going to divide, we're going to say that x divided by 2. So notice that we have this division symbol, this /. Okay, it's divided by 2. And then we're going to print out our value that we get. So this is an integer division. Okay. All right. So let's go ahead equals, and then we're going to print out the divide. Okay. So what I did was I said x, which is 10, divided by 2. Was going to be divide. Let's call it divide 1. Okay. And then we're going to do another one. Let's say, so I copy and paste. Let's say that we do x, which is 10, right? Let's say we divide that by 3. Okay. So we call that divide 2. Right. So we've done two things here, right? First we divide by 10 by 2, which we know is going to be 5. Then we divide 10 by 3, which we know is 3.3 repeating, right? So let's see what happens when we do that. Let's go ahead and click run. Okay, so notice that we got 5 and 3, okay, which is incorrect, right? But why did we get 3? So we had 10 divided, and we can even do more explicit here. Let's just make this 10. Okay, 10 divided by 3 is, and we can print out that value, okay? So when we do that, why is it 3? Well, the reason why it's 3 is that it's an integer, right? So even though it's basically throwing out everything after the decimal point, okay? So in order to get a good value for this, okay, so in order to get a good value for this, okay, what we'd have to do is we'd have to convert, we'd have to cast this, first of all, we'd have to call divide to, we'd have to, because remember, we're really doing two things here, right? We're really, we're initializing a variable, sorry, we're not initializing, we're defining a variable, right? And then we're giving it a value. Okay, so really those two lines are really one line here. So let's kind of take out our divide 1, leave our divide 2, we're just going to call it divide. Okay, so in this case we're doing two things here. Okay, we're defining this variable called divide, which is a double. Okay, let's just call it D. I know I'm changing my mind a lot, but let's just call it D. Okay, and D is going to be 10 divided by 3. Right. Okay, we don't actually need the double here in this case. Okay, it's going to be 10 divided by 3, and then we're going to go ahead and output it. Okay, so notice we get 3.0. Okay, so now let's do it again, but let's put this double here on this other side. Okay, and let's do it one more time. And notice that when we do it the second time, okay, we're defining this on the right-hand side. We're telling Java that 10 is a double. Okay, when we do that. Okay, so notice the difference here. If we take out the double here, okay, Java's assuming that 10 is an integer, right? Okay, and we run it, and it ends up being 3.0. Okay, so essentially what's happening is this side is an integer. The 10 divided by 3 is an integer. It's feeding in, and then we're assigning that value to a double. It ends up being 3.0, right? Okay, now what's another way that we could do that? Well, what we could do is we could put the decimal point on our 10 to begin with. Okay, so if we add the decimal in, then Java's going to say, oh wow, I see a decimal point. That must be a double. Okay, so notice we get the same result, right? So we take that 10, and if I type it in with a decimal point, then I get that same result, right? Okay, so we've covered a little kind of some of the intricacies here of going from integers to doubles. Okay, so you can see that we have to be pretty careful about what this implicit conversion that Java does, and that if we put in a number that doesn't have a decimal in it, that essentially Java will treat that as an integer, and then it will kind of remove parts of the number that we may not want to remove. So that when you do your programming, you have to really be sure that you're casting these variables correctly. Okay. Variable casting, it turns out, is one of the most common reasons that programs don't work, or one of the most common reasons that programs give incorrect output. Okay. All right. So what I'd like to do here is to just kind of demonstrate this. Okay, this effect. All right. So let's do just a couple different ways of doing this. Okay, so one way we're going to say this is an integer, okay? Integer assigned to a double, okay? So that is this, right? So remember that if I define this double D, but then on the right-hand side I assign it a value that is an integer, right? So 10 divided by 3, Java thinks those are I'm dividing two integers, and it's going to give me an integer output, and then when it puts in the double, that's when I get that 0.0, right? Okay. If I do it like this, okay, so I'm copying again. If I do 10.0. Okay. Okay, remember that I don't need to define D again. Okay, D for us in this case. We would know that we want a double, right? We'd know initially that we want decimal output, right? So in this case, this is a double 10.0 divided by 3 assigned to a double, right? 10 divided by 3, okay, assigned to a double. Okay. And then finally, the last way that we could do it is we could explicitly tell it that this value is a double. Okay, so we can put in parentheses here, double, and that way we can just put whatever comes in here is going to be converted to a double, and then 3 is also converted to a double, and it just works. Okay, this is actually the preferred way to do it right here. Okay, and in just a second we're going to get some user input, and you'll see why this is necessary. Okay, so let's go ahead and run this. This is let's put explicitly cast double, okay, assigned to a double. All right, so notice we get the same values here. Okay? All right, so let's go ahead. We're going to take our scanner value here, okay? And we're just going to leave this stuff in. All right, so you should have this all typed in here in your file. And let's go ahead and start to do a little bit of user input. So once again, we're going to go back to our user input. And remember that we're going to use our scanner class. Okay, so we're going to go import Java util scanner. Okay, and I'm going to paste that in, right, just under package hello, right? And I know that I need a scanner. Okay, so we're going to go ahead and ask the person a question. Okay, in this case, we're going to ask a person, what is your favorite number? Okay, so we're going to ask them a question, and then we're going to read in their we're going to notice I'm copying and pasting. In my experience when programming, copying and pasting is far more reliable than typing things out. If you want to type things out, I can tell you that will help you learn the language faster. So we got new scanner, and that's going to be system in. Okay. Let me double check it. Okay, so we got our new scanner SCR system in, and then what we're going to do is we're going to assign this to an input. Okay, so we're going to say that that double D is equal to double, and we're going to call it double scanner number. Okay. So we know that's a number having to do with scanner. Your variable types should be self-documenting in a lot of cases, but you don't want to make them too long. Okay. So we're going to go ahead and we're going to say that we're going to get this, see this SCR next. Well, let's see what is available. So we know we have this scanner object. So let's type in SCR period. And notice that that in the scanner, notice what comes up. See all these next line has next in, next radian, next long. In our case, we want this next double, right? Okay. So in this case, we're going to get the scanner to give us a double. All right. Now we could do next int or just next line, or we could just say next. Okay. But in this case, we're going to say next double, right? Okay. So we're going to get our scanner to give us our next double, and then we're going to say your favorite number, your favorite number is and notice that Java is going to automatically convert that double to a string, okay, here. So just remember that it's doing another implicit conversion, so it's not telling us that it's changing this double to a string here. okay, but it is. Okay, so I'm on this one line. So let's take a look at our lines here. We're printing out what's your favorite number. That's our prompt. We're creating a new scanner, right? Okay, for system in. We got our double. And then we're defining a double here, scanner num, and then we're also initializing it in the same line. That initializing means to give it a value, right? And that's in our scanner next double, and then we're printing out what their favorite number is. So let's go ahead and run that. Okay, so what's our favorite number? Well, my favorite number is 10.0009. And it says your favorite number is 10.009. Well, what if I hadn't have said next double? Okay, what if I said next int? Let's see what happens there. So for my scanner, what if I change it to next int? Okay, let's go ahead and run that again. Well, my favorite number is still 10.0009, and it throws an exception, right? Okay, so essentially what's happening here is that, let's take a look at this exception, right? Okay, so it's throwing an exception, and why is this? This is the most common error you're going to get. So essentially what I'm doing here is I'm telling the scanner to give me an integer, right, by saying next int, but then I'm just trying to assign it directly to a double, right? So let's try this one more time. What if I try to cast that number right here? Let's see if that works. Still throwing an exception, okay? So for the scanner in particular, we need to go ahead and use its internal, we need to go ahead and use the method for the object, right, next double. All right, if we wanted to do an integer, we could go something like this. If we really wanted to get an integer out, like let's say that we want an integer, not a double. All right, we could do something like this. Okay, so let's say it's a case where we just want an integer, right? Okay, we could say next int, right? So we have an int, a scanner int, or scr int. We do next int, right? And sometimes easier to, okay, next int. And then we could assign that to a double, okay, if we wanted to. Okay, so if we wanted to get just an integer, we could say get the integer, and then we could say that our double was equal to that integer, right? And so that should give us that explicit conversion. Okay, I'm going to go ahead. When you're programming, you want to comment just a line out, but you want to keep it. You just go ahead and put these two double slashes to comment the line out. Okay, so let's go ahead and run that. Okay, so what's my favorite number? Oh, that's interesting. I I didn't read the error very well, right? Okay, so let's run it again and let's see what that error is being thrown. Okay, and you should be doing this along with me. Okay, if I put in a 10 and hit enter, your favorite number is 10, right? Okay, but if I run it and I put in a decimal, okay, I get that error is thrown. So essentially, when I put in 10.0009, the scanner is looking for only an integer here. Okay, so this would be a real problem if you were writing code, actual code, because if the user didn't know what kind of number you wanted and they put in a decimal, that would be a real problem. So for our purposes, when we get a number using scanner, we're just going to feed it right into a double. Okay, so we're going to use next double. We're going to assume that they're going to give us, the user is going to give us a decimal or something else. Okay, so I went ahead and erased it. My favorite number is 10.009, and I'm going to run it. Okay, 10.009. Your favorite number is 10.009. Okay, so we've kind of looked at how ints and doubles are related here. Okay, so remember, a double takes up more memory. A double is a decimal, and an int is just an integer, right? we can accept that if we, if a function is looking for an integer and we feed it a double, okay, like we did for that user input, that we're going to be getting errors, right? And we'll learn to handle errors later on. But for now, if when in doubt, use a double. That's my saying. Okay, so finally, your challenge here is that I'd like you to go ahead and let's do some stuff with this number. Okay, so now we have our double. Okay, so let's do a little bit of math with this number. Okay, so there's some basic math operators. All right, so let's take, we have our scanner number. Okay, so we're going to go ahead and print out some numbers. Okay, so we're going to say scanner multiply. Okay, so let's change our scanner number. Now we can assign a value right back into the same double. Okay, so we can take scr num and we can call it scr num divided by 2. Okay, so now what we've done is we've used the variable, we've done something to it, and we've fed that value back into the same variable. Okay, so that's a pretty common thing to do. So instead of making tons and tons of different variables, if we only need to use this one time, we can just go ahead and do something to that variable. Okay, so let's go ahead and do some output. Okay. Okay, so your favorite number divided by 2 is, and then we're going to get a value. Okay. Oops. Close our line there. Okay, so our favorite number is 10.0009. Enter. And so we get our 2 answers there. Okay, so that's division, right? Okay. We can also multiply. So our favorite number times 2, okay, is going to be this star value right here. Okay. Okay, so notice that we divided by 2, then we multiply the 5.0045 back by 2 and get 10.009. We can also add and subtract, as you might suspect. Okay, so let's go ahead and copy and paste again. And this time we're going to subtract 2. Okay, so we're going to subtract 2. Oops. And we're going to add 2. Okay, just to demo some of the math that we can do. Okay. So we go ahead and run it. 0.0009. Enter. And it tells me, it gives us the correct output, right? So we can go ahead and start doing some math on these numbers, right? Okay. The next thing we're going to do is we're going to raise it to a power. Okay, but let's say we want to go beyond kind of basic arithmetic here. All right, so that's all well and good. So we have kind of our basic math operators here. But let's say we want to go beyond some basic arithmetic. So let's take a look at how we do that. Okay, so once we want to go beyond basic arithmetic, we need to start to use the math package, right? So basically what we're going to do is we're going to import static java.lang.math.star. Okay, so that star is basically telling us that we want to import everything in this math package here. So I'm going to go ahead and type this in. And we're going to put all our import statements up above inside the class. So we're going to go import okay, so java.lang.math. Oh, that's interesting. Okay, so we do java.lang.math. Okay, and I got it right. Okay, so we have the math. We have math kind of installed here. So let's take a look at some of the stuff that we can do with this basic math package. So for example, if we want to do cosine of an angle, this is an example of it. Okay, this would return a number, the cosine of the angle. Okay, so this is basically kind of mirrors what you'd be doing on a a calculator, right? So we have absolute value, return the absolute value. We can return the ceiling, which returns the smallest integer that is greater or equal to the argument. Return the floor. We can return the integer with the closest value to the argument. So this is, say, the RINT here. If we feed it a double, it's going to return the closest integer. Okay. We can also round it. Okay, so we can round a value to the closest integer or the closest long. Okay, so in this case we int, and we round a double, or we can round a float. Okay, and notice these this double with a D right here. We'll take a look at how to use that in a little bit. Okay, so we're going to do. We can also return the smallest of two arguments, right? So if we want to feed in two values, we can get the minimum value. All right. We can also get the maximum value. Okay, so these printf. So when we take a look at this this code here, essentially what they're doing is they're taking they're just defining a in their static void main, right? They're defining a few numbers and then they're printing out some values, right? So the system out printf, what this does is it says prints the absolute value of, and then we do plus, and then we do of, and then we have this code here, right? Okay, so this code is going to say is telling us how it's going to be formatted, basically. Okay, so this f and this n, right? %.3f, and then we say we're going to print a. Okay, and then we're going to print the absolute value of a. Okay, so this code right here is telling it to print a. This code here is telling us to print math absolute value of a. And notice that the decimal places, this is telling us that we're going to print a float, and I'm going to give you the wrong information here. Just one second. Okay, so what this is telling us is this % sign says, hey, this is a code. Okay, 0.3 says how many decimal places, and F says a floating point number. Okay, so notice we get %.3F, %.3F. Okay, so that tells us that each one of these is a floating point number, like a double or a float, and has 3 decimal places. And then the %n is just new line. Okay, so and then they're replaced in order. So we have, the first argument here is the line to print. The second argument is going to go in the place of this %.3f, and the third argument, which is this math absolute a, is going to go into %.3f, and then %n is separate. It's just saying that it's a new line. Okay. This is a very easy way for us to kind of exercise all of these things. All right. Now you are going to be typing this out. I, on the other hand, am going to be copying and pasting it, so you don't have to wait for me to type all this out. Okay. So we go ahead, and what we're going to do here is that we are going to be just making one value. All right. So I pasted it all in. We're going to go ahead and just kind of clean this up so it's easy to read. Okay, so that's our sample code there. In our case, we're going to be using just this SCR num, right? Okay, so basically we're just going to keep feeding in this SCR num. Okay, we do need two values here because we have to have C and D, right? So we are going to create an additional value. So we're going to call it SCR num2. Oops, let me do some space here. So we're going to create a second, we're going to create a second number. Okay, so let's take a look at what we're doing here. Okay, so we're going to exercise the absolute value, ceiling, floor, the closest integer, and the max and min. Okay, so when we've got our two values, we got our SCR num, right, which is SCR num plus 2, and then we're going to add another 2 to that, so we have two different decimal values, right, SCR num and SCR num 2. All right, so each one is the same. So this portion of the code is the same. Okay, so it's going to go the absolute value, and then of percent. So these are just how many decimal places in a floating point number. Okay, we're going to place the first one of these, so SCR num is going to go in this spot, and then the math absolute SCR num is going to go in the second spot right there. Okay. All right, so we're going to go ahead. Notice that all of these, see the F right here, and the F right here, and the F right here, and the F right here. These are all floating point numbers, right? Okay, percent point 0, that means 0, that means just one decimal place, right? Okay. All right, and then finally, we're going to get the max value. All right, so and in that case, we're going to do SCR num and SCR num 2. Okay, and I know this is a little bit confusing. This printf is confusing, to tell you the truth. There's a lot of kind of dense code that's associated with it. But once you use it for a little bit, it makes more sense. Okay, so once again, we're going to replace that here. Okay, so this is going to be kind of your challenge for our thing we're doing, our assignment here. All right, so here's what we have. All right, so let's take a look at the code, all the code here. All right, and I'm sure when I run it, I'm going to get some errors. So let's go ahead and run it. Okay, it says so some errors exist. So let's look at our error. Oh, I forgot. So this SCR num. And I never defined SCR num 2, right? So I have to define it as a double. And then we're going to go ahead and run it. Okay, so what is my favorite number? My number is still 10.0009. Enter. Okay, and I got all the way down to R int. Okay, so obviously I just kind of told you the wrong thing here. The R int is 10. So notice that when we do a 0.0, we're saying no decimal place, right? Even though it's a floating point number. All right. So why is it that this gave us a value? All right. So let's go ahead and read our exception. Exception thread main and then deleted exception, and we say D does not equal Java-lang double. Okay. So let's take a look at that. Okay, so what's our problem here? So we got an error, and so what's our problem? So we need to go back and look at math max. Okay, and we're trying to replace a %d, so we would need to go look up that printf function, okay, which we already have. Okay, so the printf, if I say a d, we're saying a decimal integer. Okay, so it can be a byte, short, int, or long, but not a float or double. Okay, so let's go back and change that. All right, so we need not %d, we need %f. Okay, because our numbers are doubles, right? So let's go ahead and run it again. So what is your favorite number? still doing wrong. Still doing the wrong thing. Oops. And notice I still had %D's in here that I forgot to replace. So notice we're on this last line. All right, so we're going to go ahead and run it one more time. Okay, and there we go. So the max, so let's take a look at our output. And so your favorite number is 10.0009. If I divide it by 2, it's this. If I multiply it by 2, it's this. If I subtract 2, it's this. If I subtract 2 again, whoops, but I didn't subtract 2, I added. Okay, and I'm going to just change up here. So we had a double your favorite number, your other favorite number. Let's say your other favorite number plus 2 is, and I'm going to put in an SCR number 2 just so it makes sense. Okay, let's run it one more time. 0.0009, enter. Okay, so we get kind of our sample math here, all right? So we kind of went into a lot of different subjects here. So basically we talked about what the difference is. We talked about the primitive integer types, or sorry, the primitive data types in Java. We talked about the difference between int and double. We talked about doing kind of basic operations with numbers, you know, your basic arithmetic, you know, division, multiplication, subtraction, addition. Then we talked about importing the Java Lang math, and then we talked about a little bit about how to use that Java Lang math and how to print it out. Okay. So I'm going to go ahead and leave this code on the screen. So basically, you know, you can rewind the video to get this top part of the code, which you'll need to have. And then if you scroll down and just pause it right here, you can go ahead and type in the second part of the code. It should run with no errors, and you should be able to get the same type of output that I got here. Okay, good luck.